Can you guys see this?
Yes.
Okay, cool. So, and I guess we can start working on the warm-up. The warm-up's right here, and you can take as long as you want. Probably till 10 more minutes from now, and then wait for everyone to come back. Oh, sorry. Hey, David. How are you today? You can type in chat. Oh yeah, if you guys are done, you can send the answers over to me on private chat, or you can send the answers to Eric as well. And we can both check if it's correct or not. Okay. Okay, 3 minutes. Oh, hey there, Stella. We're doing the warm-up right now, so once you are done, you can email me or Eric the answers, and we can both check if you got them correct or not, okay? Okay. See, okay, more people showing up. Okay, it's now 8:30. Okay, I'll just wait a few more minutes to see if anyone else shows up. I feel like I'm still missing a few people, and then we'll get started. Okay. Oh yeah. For those who just arrived, we're doing the warm-up right now. And when you guys are done, you can send me the answers, or you can send Eric the answers to see if you guys are correct or not. Huh? Oh, okay. Let's do that. Can you guys hear me loud and clear? Just type a yes or no. Yes. Okay. Cool. Okay. Just wait for a few more students to arrive. Okay. Give them another 3 minutes. Oh, yes. That's weird. Sorry. Give me a second. Okay, there you go. Sorry about that. That was weird. Oh, hey, Andrew. Okay, pull this up again. There you go. This over here should be fine. Oh yeah, if everyone can have their cameras on, that'd be great. It just helps me get to know you guys better. Okay. Yes. See, Andrew has discovered it. Wave. Yeah. Hey, Nicholas. Welcome back. Okay. I think let's get started. For anyone who just arrived, we're just doing the warm-up. I think I'll give you guys another minute or so, and then we'll be basically skip to the next part. So just really quickly do it. If you guys don't have time to finish it, don't worry about it. Okay, one more minute. You guys can tell me if you guys need more time, okay? Okay, time's up. Just like last class, we'll be loading the answers into the chat, and then I want everyone to press enter at the same time so that we get a waterfall of responses, okay? So can you guys load into the chat the first question, the answer to the first question? Okay, you guys ready? 3, 2, 1, go. Great, okay, yeah. First one's pretty easy. I don't think I need to go over that. So let's go to the second one, okay? Put that in. Okay, and then press enter in 3, 2, 1. Okay, go. Stella, you're a bit too early. Okay. Okay, most people got it. I think Nicholas, you typed it a little wrong, and then Alan, I think, yeah. So, okay. So let's go over this one because some people missed a little bit. This went the wrong way a little bit. So let us drawing for it. So when I see this 9 being multiplied by the 13, I don't want to use this big number and multiply by 3 again because that would be very hard in my opinion. So what two numbers would you think are the easiest to multiply together? Anyone can say this. Anyone can type in chat. So yeah, which two numbers you guys think is the easiest to multiply together? Is it the 9 with 13, the 13 with 3, or the 9 with the 3? Yes, 9 times 3. And you guys know what that is? That is 27. So that's pretty simple, right? Now, all I have to do is times it by 13. So I get is I first times 7 by 3, which is 21. Oh, and then now 7 times 1 plus 2 is 9. Oh, yes, and then now I go with 2 times 3, which is 6. And then 2 times 1, which is 2. Now what I get is 9, 1, 6, 2, 6, sorry. And then we add that together, and this will be a 0. So then we go down the row, and then there is a 15 here, so we add 1. We carry this 1 over, and then now we get 351. You guys got that? So in this case, we use the associate property that we learned last class and the cumulative property to move the 9 over and first do 9 times 3, which makes the equation much easier than having to do 9 times 13 and then times 3 again. Okay, you guys have any questions? No? Okay, let's go to the next question then. Okay, yeah. Well, it's all honestly up to you which two numbers you want to multiply together. But for me, I think that would be the easiest. Okay, for the third question, let's learn the answer and then we'll press enter at the same time when I count down. Okay, 3, 2, 1, enter. Good. Yeah, there's a lot more people answering now. So you guys remember this question? What's so special about this question right here? Does anyone know? Does anyone remember? You guys can type in chat or just talk. Okay, Andrew. Yeah, you can unmute.
So basically, do 1 plus 99, that's 100. So basically you do that until you get to 50 and then.
Yep. Yeah. It was just the question that we did yesterday as well. Yeah. So since there's basically half of 100, which is 50, and there are these pairs that add to 100, what we can do is basically say 50 divided by 2. All right, let me draw that. 50 divided by 2, which is 25. And then that times 1 plus 99 or 3 plus 97, which is 100, and you get 2,500. That's good. Okay. And then how about the next question? You guys load the answer into chat and then we'll press enter at the same time again. Okay, 3, 2, 1, press enter. Ooh, Andrew, you're fast. Did anyone else get the question or the answer? Oh, Andrew, you're the only one. Okay. Okay, I'm the guy as well. Do any of you want to explain it? Or explain how you got it, how you guys got it? Okay. Wanna go again, Andrew?
So it's basically the same thing except you have the 100 at the end, I'm pretty sure. So 2 plus 98. So you add 100 you add 50 again because you add another 100, I think.
You close, but you don't add just 50 at the end. But think about what you did in the previous question and why we did 50 divided by 2 and then times it by 100. But what about now? Like what I said with these groups. So Andrew, what group, how big are the groups now? Or what is their value?
So it's 2 and 98, and then you do 4 and 50.
Yeah, but there's 100 now. So what would this be?
102.
Yes, 102. So now these groups are 102, right? So 20 plus times 102 is what?
2,550.
Yeah, see? 2050. Oh, hey, Ian. So basically that's how you get 2,550. So it's not that difficult. All you guys have to do is just think about the groups and how they group together like that. Okay, does anyone have any questions? Okay, I guess let's go to the next part then. And clear this. Does anyone have any questions on the homework that I sent out last night? Oh, first off, did everyone receive the homework?
This is my first class.
Okay, yeah. There's some new people joining in, so sorry if I couldn't send to you. But for those who received the homework and hopefully you guys done it, are there any questions on the homework? You guys can type out on chat in chat. No? Anyone else? Okay. I guess the homework is pretty easy. We don't have to go over that then. So on to the next slide. So just a friendly reminder, I would love to have a camera on. It would be my dream. You guys know what a dream is. As a teacher, to have your camera on and to actually see your faces so I can interact with you. So like with Andrew, I can actually see him and interact with him much better than say other people like Eric. Sorry, call you out. Okay. Let's go to the next slide then. Okay, so today we'll be going over the order of operations. Does anyone have an idea of what order of operations are? Or okay. Sorry, Andrew. I'm trying to get someone else to answer. Does anyone else other than Andrew know? How about you, Nicholas? You know? You can unmute or type in chat. You've heard it before. Okay, cool. It's okay if you don't know. Okay, you have not heard of it. Well, that's a good thing since we'll be teaching it today. So remember last class, or for people who weren't here, we had a question talking about how 2x times 3 plus 7 equals what? We got two results, which was 13 and 20. And you guys know how that happened? Well, it was because what we did is that we either did the multiplication first and got 6 plus 7, or we did an addition first and we got basically 2. Let me draw this out. So instead of 6 plus 7, we got 2 times 10. And that led to two different answers. But does anyone know which one is correct? Yes, it's parentheses. Yes. Okay, so David, you do know the order of operations. Yes, okay. Yeah, so it's 13 because we have to follow the order of operation in order to make sure that whenever we solve expressions like these, we get the same result. And we follow the proper order of solving it. Okay, so let me clear this. So what is the order of operations? The order of operations is the order where we carry out different operations. So addition, subtraction, division, and multiplication. And for like United States, we use the term PENDOS in order to show which operations go first, which means parentheses, exponents, multiplication, division, addition, and subtraction. So yeah, basically the slide says. And then I have basically a brief picture, or actually an acronym to describe or help you memorize PENDOS, which is please excuse my dear Aunt Sally. Does everyone know what aunt is? You guys can type it out. Yes, it's your mom's or dad's sister. So that would technically be your aunt. Okay, good, Andrew. So basically what this is saying is that we use these words and the sentence to help us memorize PENDOS and things like that. So P is for parentheses, E, exponent, M, multiplication, D, division, A, addition, and S, subtraction. Okay, and then I have a quick video for you guys to watch, okay? I think this will be pretty fun. Can you guys hear this? Okay, cool.
Once upon a time, in the magical and very round land of Pi,
Oh, it's
there
dim.
lived 6 swashbucklers.
What do you mean by dim?
I mean, like the noise, it's like you can barely hear it.
Oh, okay,
It's
okay.
not really noise.
Okay. Let me try and figure this out for a second.
Like at the bottom where the speaker is next to play, you can just like raise the thing. It'll
Okay.
make volume. Like if you hover
Okay.
over, you'll see like a bar.
I think I got this. Okay, I shared the sound. Yep, there you go.
Musketeers. Their names were parentheses, exponents, multiplication, division, addition.
Better, okay. You want to do it a little softer then? Okay, okay. Let's start over then. Good.
Once upon a time, in the magical and very round land of Pi, there lived 6 swashbuckling musketeers. Their names were parentheses, exponents, multiplication, division, addition, and subtraction. But each was known best by his or her mark. The 2 hands ready to catch a fly of parentheses, the small and raised digits of exponents, the mighty X of multiplication, slash of division, plus of addition, and, well, you can guess the symbol by which little subtraction was best known. The land of Pi was not necessarily the most peaceful place, and that's why the numbers of the kingdom needed the musketeers. The land of Pi had been ruled by the numbers, as an anarcho-syndicalist commune, each number with a vote. But one powerful number from what we'll call the Imperial Senate engineered a war between some robot things and the knights of the kingdom, and then installed himself as supreme emperor. And then Puff the magic digit dragon ate him, and a princess or two. And, well, all the other numbers in the land of Pi actually. It was kind of a big day. Anyway, the musketeers were called to action to save the land of Pi from the voracious dragon. They rode towards him on their valiant steeds and attacked. First multiplication, then parentheses. But that didn't work. The dragon continued eating people. So addition tried, but was thrown aside. Exponents leaped at the beast and was quickly squashed. Nothing was working. The musketeers huddled and formulated a plan. They would attack in sequence, but who should go first? They bickered for a while. The dragon ate a few more princesses, and then they finally agreed. They jumped into the first, smallest parentheses inside the great Puff the digit dragon. Parentheses pointed out where to work first and protected exponents, multiplication, division, addition, and subtraction while they diced and sliced. First here, then move over there, then there. Look out, there's another set. Parentheses pointed and exponents took the lead. Then it was multiplication and division, addition and subtraction, each in turn, always the same order, P-E-M-D-A-S. When they finished that set, they went to another and another, always working inside the parentheses in PEMDAS order. Pop, 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 pop. PEMDAS, there's another spot. Don't forget there can be parentheses inside parentheses. There's one, and that tricky exponent. There we go. Finally, the PEMDAS musketeers had whittled Puff down to his last fearsome roar. But having vanquished Puff the magic digit dragon, all the Empire's numbers sprang again from this tiny little number 1. And they all lived happily ever after. Except for the Emperor number, which they threw into the mouth of an ancient creature nesting in the desert. The end.
Okay. So you guys, let's go to the next slide. You guys understand the video? Oh, sorry. Next slide. There we go. So let's talk about why PEMDAS is important. So when you guys watch the video, did you guys understand why the operations cannot defeat the dragon at first? Does anyone want to say why? Okay, Lori, go. You can type in chat or you can unmute your mic.
Because the dragon is stronger than them, and they could just do it in order, and then the dragon would be defeated.
Yes, because all the knights had to go follow an order called PEMDAS in order to defeat the big puffed magic dragon. You can see him on the bottom right here. So again, like the video said, the reason that PEMDAS is important is that imagine there are multiple operations in a single equation, like what I shown here, 2 times 3 plus parentheses 9 plus 3 parentheses divided by 2. So in this case, we need to use the order of the operations to solve this mathematical expression. So basically, what we will be doing is that we'll be first using parentheses, taking the 9 plus 3, which is 12, and then we'll be dividing that by 2, which is 6, multiplying this, which is also 6, and then now you get 6 plus 6, which is 12. Okay? So again, this is different from associative property that we learned last class, since we'll be changing basically not just the numbers, but also the order of the equation with how we're doing it, basically. So unlike associative property or cumulative property, we have addition and multiplication at the same time, so we can't change or move around numbers so much. So basically, like I said, if you change the numbers around in the order where you do it, you'll get 2 different numbers. Okay, does all that make sense? Cool. Okay, let's go to the next slide then. Okay, so let's go to the first order operation, which is parentheses. Parentheses is the first operation in PEMDAS, and all it really represents is you first do the addition, multiplication, division inside the brackets first. So for example, with 2 plus 3 times 4, we do the 2 plus 3, which is 5, and then times 4 would be 20. And then also, just for you guys to know, is that if we put numbers next to parentheses, that means that they're being multiplied. So for like 3 parentheses 4, it means 3 times 4 are 12. Okay? Does all that make sense? Okay, let's go to some practice and let's do some practice. So we have 3 minutes and you guys can do these. Remember that it is very important that you guys write these problems down on a notebook sheet of paper so you guys can move around numbers as you would like using associative and cumulative property. Again, you guys can check with me or Eric. Sorry, give me a second. Exit this, close this, and then I'll set this back. Okay. right side. Could you explain that a little more, David? I don't really know what you mean by that.
I think I do know, like in problem 4 and 5, I think it's like that, like the things beside it, maybe.
5? Oh, right side. There's a left side and a right side. Okay. You want me like label them? Like, is that what you mean? Like,
No, like because I'm pretty sure that means multiplication.
oh, okay, yeah. So this is just multiplying 2 with 3. I'm just checking that you guys understand what that means. Okay, yeah. You're just multiplying. So 2 bracket 3 is another way of writing 2 times 3. So it's very simple. Okay. And then I think we should be good. Okay. So you guys, let's do this again. We are going to load in the answers to the first question, and we can press enter at the same time in 3, 2, 1, go. Okay, most of you guys got that correct. Andrew, I think you accidentally did 3 times 2. This is a plus. Don't worry, don't worry. Yep. Okay, most of you guys got that correct. So now let's do the second one. 3, 2, 1, press enter. Okay, nice. Most guys got that. I don't think I need to explain that. Okay, now for a pretty tricky one, the third question. Ready? 3, 2, 1, press enter. Okay, you guys a bit early, but okay. Yeah. Okay. Okay, Lori, we do the parentheses first, so let me think. Oh, sorry, yeah. Okay. Sorry about that. Okay. So I don't think you guys need to go over 4 or 5 since those are pretty easy. How about 6? Let's do 6. Load in the answer for 6 and press enter in 3, 2, 1, go. Okay, good. Okay. A lot of people got this. Okay, cool. Then let's go on to the next slide. And then basically, next slide is about what is exponents and PEMDAS. Exponents say the amount of time that a number is multiplied by itself. So exponent is like writing an exponent is having a big number like right here, and you're adding a small number onto its top right hand corner. So right here. So an example of an exponent would be 3 squared, which is just 3 times 3 root of 9. The exponent of an equation of like 3 to the power of 3 would be 3 times 3 times 3, or 27. Another example would be 4 to the power of 5 would be 4 times itself 5 times. Okay? Does everyone know or got exponents? Does that make sense? Yes? Okay. Yeah, you guys can put a thumbs up. That'll be fine as well. Okay. So we got that. So let's go to the problem questions then. Okay. So here are the problems with exponents. You guys have 5 minutes. And this will be building on what we learned with parentheses as well. Okay. Yeah, sorry if I can't get back to you right away. There's a lot of students talking to me right now. Okay, that's weird. Okay. I don't think. Let me think about this. What do I think this? Okay, that's weird. Hmm. Yeah, I think timer is about to go off. Can't tell. Oh, there you go. Okay. Turn this off. Oh, let me go back. Okay. So let's learn to answer the first question. And 3, 2, 1, go. Okay. Good. Okay. I think everyone got that. So let's go to the second question. 3, 2, 1, go. Good. Okay. And now the third question. Very similar to one of those top questions. In 3, 2, 1, go. Okay. Nice. Okay. Okay. Now let's go to question 4. And 3, 2, 1, go. Good. Good. Okay. Now let's go to question 5. A little harder, but shouldn't be too hard. 3, 2, 1, go. Okay, now for the last question. 3, 2, 1, go. Okay, okay. Oh, shoot. Okay. Yeah, sorry, Andrew and Laura. I think I responded to the wrong people. Yeah, you guys are correct. Yeah, okay. Let me just quickly do this one. So some people missed this, which is do 6 squared, which is 6 times 6, or 36. And then we have 3 to the power 3, and this is 27. So 36 times 27, we have a 2, 4, carry the 21, so 25. You have the 2, 1, and 3 to 7. So now you're at 2, 7, 9. Okay, you guys got that? Okay, cool. Let's go on to the next slide then. That's pretty good. And now, and of course, multiplication, division are next in the order. So you do these after parentheses and exponents. And after that, it's just addition and subtraction. Just make sure that you follow the order. And if you see parentheses, you always do them first. Okay? So let's end off with multiplication and addition. And I'll give you guys 2 minutes. Few more seconds left. Okay. Okay, and time went off. Okay, so honestly, I feel like these are pretty easy. Does anyone need to go over any questions, or did anyone struggle with anything? You type in yes or no. No questions? No? Okay. You guys are good. Let's go on to the next slide then. And now we're going to put all these together now, okay? And I'm going to implement everything that we learned with parentheses, multiplication, exponents, and everything. Okay? Let's get started then. Okay. Give me a second. Okay. Give me a second. Yeah. Hmm. Sorry, I'm fit backlog a little bit. Okay. Does anyone need more time? Okay. No? Okay, let's go over the first question then. Load in the answers and press enter in 3, 2, 1, go. Okay, cool. Let's see. Yep, most people got that. Okay. Let's go to the second question then. 3, 2, 1, press enter. Okay. Okay, I don't know where you got that number from, Nicholas, but you are very close. I think you timed it. You timed it by 3 somewhere. Along those lines, or something along those lines. So what we do first is the exponent right here. So we get 25 because 5 times 5 is 25. Then now we do multiplication next, times 2, we get 50, and then we add 4, which is 54. Okay, you got that? Okay, let's go to question 3 then. Okay, 3, 2, 1, press enter. Okay. Okay. Let's do this then. Since there's a division and if it's 36 or is it 18. So let's solve this then. So let's first do parentheses, which is 1 plus 2, which 1 plus 2 is 3. Then now what's next is exponents. So now we do it by 2. So 3 squared or 3 times 3 is 9. Now 2 times 9 is 18. So the answer for question 3 is 18. You guys got that? Okay, cool. Let's go to question 4 then. And 3, 2, 1, press enter. Okay. 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 I think I see what you did, Nicholas. Maybe. Okay. So again, remember there is a parentheses first, so we do that first. So that's 7. 4 plus 3 is 7. Now we do this right here, which is exponents. Exponents, which is 25. So after we do exponents, now we do multiplication, which is 25 times 7. But I also see that there is a division of 7 right here. So what I can do is that since I'm being times 7 and dividing by 7, I can just cancel that out. You guys catch that? I can just cancel out times 7 and divide by 7 because it's the same operation. So what I get is just 25. Okay, cool. Now let's go to question 5. Okay, 3, 2, 1, press enter. Okay, well, most of you guys got that. Okay. Again, it's just 36 plus 2. You have 38 times 2 equals 76. Okay, now let's do question 6 now. 3, 2, 1, press enter. Okay, good. Wow, a lot of you guys got that. Okay, let's go over this way quickly again. So we see this parenthesis right here. Let's do this part first. So 3 times 4 is 12. Now we divide that by 6, and that's 2. So now after that, we do multiplication between 4 and 2. So 4 and 2. Now we get 4 times 2, which is 8. Now after that, we do division. Next, 100 divided by 2 is 50. And then we finally add the 50 with the 8, and we get 58. You guys got that? Okay, cool. Does anyone have any questions? Okay, let's see. It seems like we don't have a lot of time. So I think since you guys didn't really, let me see, we don't have enough time for a quiz. Would you guys rather do distributive property first, or would you guys want to take the quiz? I'm going to say a little after class for the quiz. You guys can type 1 for a quiz, or you can type 2 for a distributive property. You guys want to learn something else. 2, okay. Anyone else? 2? Okay, okay. Then we'll probably save the quiz for beginning of next week then. Okay. So distributive property. Has anyone heard of it first of all? Oh, Laura, you heard of it. Okay. Can you describe to me like what you think it is?
The distributive property is like when it's like 2 and then time like something in these parentheses, or anything like time something in the parentheses, but actually it's like 2 times the first thing in the parentheses and 2 times the second thing in the parentheses, like for example.
Okay, yeah, that's completely correct. So when there's a parentheses and there's addition, like 2 plus 3, what we do is that we can separate this basically into 2 times, so 3 times 2 plus 3 times 3, and we still get the same result, even if we solve this first. So this is another way of solving, basically. Okay, very simple. Everyone got that? Okay, let's go to okay, yeah, so let me just make an analogy very quickly. So say if I was a mean teacher, I give you 1 more page of homework, you have 2 pages, then there'd be 3 pages now. If you print that out twice, you use 6 pieces of paper. But how about instead, I decided to save 1 sheet of paper for tomorrow, and now instead of having to do 3 sheets of paper, you have 2 sheets tonight and 1 sheet next week. So in total, how many sheets of paper will you guys use for today and tomorrow, or today and next week? You guys can type it out in chat.
Wait, is it with both, like you're the mean teacher and the nice teacher?
Oh, no, I'm talking about just the nice teacher. If I decide to save that 1 sheet of paper for say next week, now how many sheets of paper would I use for this week and next week? Like if you guys need to print it out twice.
6.
Yes, 6. Okay, yeah. That's what I'll try and go for. Yeah, okay. So this will be the last thing you guys do. Just do some quick problems. It shouldn't be too hard until the rest of class. Okay. Okay, and then in chat, I'll just, oh, it's not it. Okay, I'll share it to you guys in chat in a second. The link to the, oh, I can't copy? That's weird. Hey, Eric, can you just type it in chat? Just send them to talk to everyone. Okay. Okay. Can you guys learn the answer to the first question in chat? Okay. 3, 2, 1, press enter. Okay, good, good. Okay, I think everyone got that. Let's see the second question then. 3, 2, 1, press enter. Okay. Yeah, Andrew, you're originally correct. I thought you put that for your first answer. Sorry. In the future, you guys should label out which question is from which. So I kind of know, okay, if this is correct or not. Okay. And David, you were very close, very close. I think you went 1,000 over. Yes, yes, there you go. Yeah. Could have just been a typo. Okay. Yeah, yeah. No problem. So now let's do the last one. 3, 2, 1, press enter. Okay, good. I think everyone got that.
I just want to say one thing for question 3.
Yeah.
If you just do 1 plus 10, so 11, and then my trick for doing 11 times anything is just you add 3, like in this case 3, 5, and you add the other 3 to the 5, and then you just add the 5 at the end. So,
Yeah, that works as well. We're just using distributed products to show like another way of doing things. If you have a better way of doing things that's faster, that's completely fine. But I will be using distributed property in other problems, such as using variables in the future, okay? So this would be something that you would need to know and need to use so that you can solve questions like this in the future. Okay, and then that's it. But that's all for today. How was class today? You guys think it was easy, just right, or you think it's hard? You guys can do 1 for easy, 2 for just right, or 3 for hard. Okay. 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 Anyone else want to answer? Okay. No one else? How about Alice? What do you think? Okay. It's time to go. I held down a little too long. Well, I guess yeah, class is over. I will see you guys next week then. Okay. You guys can leave now. Okay. Bye. No problem. Yeah. See you guys next week.
See you next time.
Yes. Yes.
Bye.
Yeah. No problem. Okay. Anyone have any questions? So Eric, what do you think? Was it better or?
Yeah, it was a good class. I feel like a lot of students like they message you because they don't want to like publicly say that they have like issues,
Yeah.
which is like understandable.
Yeah. Wait, do you see the message to me or no? Okay, the message to me. Or did you get any messages at all? Like privately?
Oh yeah, direct messages.
Like private messages for like questions. Answer questions.
Like, can you send me the homework link?
Oh, is that it? Oh, no, like students asking you if the question was right.
Oh no. They're
Oh,
probably
okay. Yeah. Oh, students were asking me nonstop. So also I was like, you saw me kind of busy typing and things like that.
yeah, I realized that after a while because like I feel like the kids are
Yeah, yeah. I mean,
yeah,
I can tell them to ask you.
they don't really know me. You're a teacher. You sound really nice. So like, they don't know me. So like, what are they gonna do?
It's fine. I mean,
No, what I was talking about was that for order operations, like addition and subtraction, you should like tell them it's from left to right because
yes,
like
yes, yeah. I realized that, but I kind of already went over in the previous class that for associative and commutative property, you can only use addition and multiplication and not subtraction. Subtraction messes the whole thing up. So I think
yeah.
I may have like failed to make that point, but I'll do that next class. I'll definitely do that next class.
Okay. Also, I made you the host because I don't know how to end the class.
Oh yeah. Okay, yeah, the host left. I think I can press stop recording. I also have end right here.
Uh,
So yeah, it seems like a lot of students already know these things, so I gotta step up my game. I don't know about the other students though. That's not an issue. They don't talk to me. They're still like Stella, like Ian. You guys still in the call. I
are they sleeping?
I don't know. It's the morning right now. It's the morning right now.
It's pretty late in the morning. You don't really usually teach at this time. I
Mhm.
mean, you like, you know what I mean?
Mhm.
Like,
Okay. Yeah. Thank you so much. Yeah. Well, I guess I'll be ending class and
okay,
there. Yeah.
are
Yeah.
you watching the movie?
Yeah. Just please make sure to send out an email, okay?
Okay, wait, how do you send an email? You
Send out
just put,
Yeah, I had to type out the names on the email sheet by hand, so I think either I can
oh,
send you like full
okay, so
list, or you want me to send you full list, I can forward you like the email and then you can BBC, things like that.
I'm like, what is BBC?
It just basically hides the emails of the other parents, just for courtesy's sake and confidentiality.
Oh, so you send it separately, like one at a time?
Basically, the email, Google or whoever does that automatically for you. So that's what BBC means. Sorry, BCC.
I'm not that advancing in emails. I'll
Yeah,
try it out.
no
Okay.
problem. Yeah, my friend taught me this actually a few days ago.
Oh, wait, is it like an option? Like, where do you see it?
Yes, there is an option to just do CC, which is carbon copy the email, and then I think BCC, I forgot the name, but you basically maybe business carbon copy. So instead, you have it so that it basically emails.
Okay.
Mhm.
Emily says hi.
Oh, hi. Like, can she hear me? Can she see me?
She can hear you.
Okay, hear me. Okay, okay.
Okay. I'll text you when we're watching the movie. Okay.
Okay, that sounds good. Okay.
See you later. Bye.
Bye. Also, this is recorded.